I'm Anil Kumar, and in this video we will consider period of a sinusoidal function. So when we are considering different time periods, then the equation will mainly be y equals to sine of kx, right? So we are considering very simple equations at present, so I'm not considering any other changes in the basic sine function. The only change which we'll explore in this particular video is the one which will reflect on the time period of the function, right? We have already considered amplitude in another video. We'll consider translations in the next video, and then combine these and then look into the transformation of sinusoidal functions in further details, right? So let's look into each component separately and then we'll move forward. So when I say y equals to sine kx, then what really happens is that the time period changes. So normally the time period of y equals to sine x, let me write down the basic function, which is y equals to sine x, right? And let's compare these two. Now in these two functions, they are exactly same with one difference, and the difference is time period. So time period here is 2 pi. So that means after every 2 pi radians, the cycle will repeat. Or in degrees, I could write this as 360 degrees. However, if I have sine kx, in that case the time period is 2 pi divided by k, right? Or I could also write this as equal to pi is 180 degrees, so you could multiply by 180 and you get 360 degrees divided by k. So both are one and the same thing, correct? As you know, let me write down here, pi is equals to 180 degrees. So that is the conversion factor, right? So we'll utilize this knowledge to sketch some graphs, and also from the graph we can write down the equation, right? So let me start with the basic sine function, which is let us say like this, right? So let us say this is our basic sine function, and we say this is the graph of sine x. So we are writing sine x here, and since it is the graph of sine x, it has a time period of 2 pi, so we'll write 2 pi here. Maximum value is 1 and minimum is minus 1. Now what we are going to do here is sketch other functions which are related. Let us say we want to sketch a function which is sine of 2x. Then how should that function be? Now if the function is sine 2x, it means that the time period will be how much? 2 pi divided by 2, that means pi, correct? So in this particular case, time period t is going to be 2 pi divided by 2, and that is pi, correct? So that means that particular wave sine 2x will be like compressed horizontally by a factor of half. Do you see that? So this particular wave is compressed horizontally by a factor of half. So what I mean to say by a factor of half is that each and every point on the sine wave, for example this 0 will move to half the location. So this 0 will appear here. This peak will move to half the location, correct? And this peak will also move to half the location. So effectively what we are going to have here is that we'll have one wave in half the time period of the original function, right? So we have a wave which is kind of like this. So this is sine 2x. Do you see that? So sine 2x will be that particular wave. So it has now a smaller repeating cycle, or the time period here is just pi, not 2 pi. Do you see that? So that is what sine 2x is. So this is one way of looking into it. The other way of looking into it is that in 2 pi we will have two waves. So we will have actually in 2 pi two waves. So if I repeat this wave here, right, so what do I get here is two waves. So we will be going like this, so there will be two waves. So interpreting sine 2x is in two different ways. One, we interpret as two waves in normal time period of 2 pi. Do you see that? Or one wave in pi, or you could say that is time period equals to pi. You get the idea, right? So that is how it is. Now moving forward with this information, now I'll give you few examples and you write down the time periods. So now we'll look for sine of half x. So what do you think is the time period of sine of half x, and what do you think is the time period of sine of let us say 5x? Okay, and in one 360 degrees, for example, how many waves will be there? Let these be the two questions to be answered. So sine of half x means what? So let's try to sketch this one. We'll sketch just one wave, right? So sine of half x really means that if I draw a wave, sine wave, then its time period is going to be how much? It is going to be, let us calculate. So time period for this particular wave will be equals to 2 pi divided by half, which gives us 4 pi. Do you get it? So this wave has a time period of 4 pi. That is sine of half x. So this is 2 pi. Do you understand? So within time period of 2 pi, there will be only half of the wave. So half wave in 2 pi. So you could see like this also. So you could relate this as half wave in 2 pi. Do you see that? So that is another interpretation of sine of half x, right? That's very important. So going with this reasoning, sine 5x means what? It means 5 waves in 360 degrees. Do you understand? Or 2 pi radians. Do you understand? That is what it means. And it also means that the time period of this wave will be equals to 2 pi divided by 5. And therefore you can have 5 waves in 2 pi, correct? Or that is also same as 360 divided by 5 is going to be your time period, right? So you can of course simplify and write down your answer. In this case will be 70 degrees, right? Okay. 72 degrees, correct. Now, likewise, I think you understand how the sine waves time periods get affected. Now, if we are working with cosine function, then also it is exactly same. So let us say now we have some examples for cosine function. Let's say we have f of x equals to cos of 3x, and then we have g of x equals to cos of, let us say, half x. In that case, can you tell me, or can you sketch this function for me? Okay, so let us try to sketch the functions. Let me do a small sketch here. Cosine function, as you know, and we'll do a small sketch here. Okay, cosine functions start with maximum, and therefore we could always start with maximum and make one cosine wave. Here also we'll start with maximum, make one cosine wave. You know, 1 and minus 1 are maximum minimum values, easy. But the only thing which changes is the time period. When we say cos of 3x, the time period is 2 pi by 3. Do you get the idea? And when I say cos of half x, then the time period is how much? 4 pi, correct? 2 pi divided by half, or in degrees, 720 degrees. Do you understand? 720 degrees is the time period of cosine half x. It is horizontally stretched. We will say this is horizontally stretched by a factor of 2. Do you see that? Twice. So the time period will not be 2 pi or 360, but twice 2 pi or twice 360 for cos of half x. For cos of 3x, we'll have 3 cosine functions waves within 2 pi, each with a time period of 2 pi by 3, or 360 divided by 3, which is 120. So time period for this will be 360 divided by 3, since that number is 3, will give us 120 degrees. That is the time period. So I hope with this particular video you can now appreciate how that k factor in the equation affects time period for the sinusoidal function, right? Of course, sinusoidal function could be in the sine form or cosine form. The time period normally is 2 pi, but when it is transformed, then it is 2 pi by k. And these are a few examples which will help you to understand this concept. Let's move forward. Thank you and all the best.